This video is a short description or draft of a small project using agents and AutoGen. Personally, over the past few years, I've developed the habit of only checking negative reviews whenever I need to buy a product or service. I also filter out the ones that don't seem to make much sense. The reason is that most of the times I relied on positive reviews to make a decision, I ended up disappointed. And when I later went back to check the negative reviews, I found that a good percentage of them perfectly described the same frustration I experienced. So, for me, negative reviews or opinions tend to be way more consistent with reality and more reliable than positive ones. This applies not only to consumer products but also to professional services, and I also find it to be a great habit when making investment decisions on any financial product. Reading the description and promises of a product, stock company, or anything else, while they may sometimes be independent opinions, doesn't really add much value. And the ability of mathematical formulas and economic theories to model scenarios which worked well 10 years ago can now be undermined by a single tweet meant as a joke. Finding a good number of negative reviews among the vast amount of opinions available is a lengthy task. Even more tedious is trying to analyze all those negative opinions, finding justifications for them, and link them to a specific reality. For this reason, having LLM-based agents capable of processing text can greatly simplify the work. If we also use multiple agents working in parallel for independent tasks and make asynchronous requests to language models, then a complex task can be completed much faster. This is just a kind of sketch project, but as you may have seen, the interface allows you to enter the names of companies and tickers freely without freezing the screen. It works independently with each input, collecting information and refining a report on the selected company. First, it gathers all kinds of opinions and comments about the company. To classify these comments as positive or negative, it uses a locally running open-source LLM. Once classified, another agent will synthesize all the negative comments into a list of key points. At the same time, a detailed report on the company is being generated independently in parallel. Asynchronously, multiple agents focus on analyzing different aspects of the company, and their reports are combined into a single document. This document company resume.json. With these two documents, the concern summary and the company resume, another agent will use them to establish coherence or identify connections between each of the main negative concerns and the company's overall information. This results in a final document that contains a structured list of concerns, reasons for each concern, context, and different suggestions. This is already a decent report, and it's already great for personal use. But to polish the final document a bit more, we can run it through several agents, each focusing on different aspects such as clarity, legality, or any other relevant factor depending on the document's final purpose or destination. Each agent provides suggestions which are then applied to refine the document. Okay, and now that the general idea is clear, let's go through the exact same process again, but this time with a deeper look at a more detailed diagram. Every time we input a stock into the user interface, we trigger a new independent process on a separate CPU core, dedicated exclusively to that stock. Since we want to speed up the process as much as possible, instead of running everything sequentially on a single core, as it's clearly illustrated here, we allow each process to grab an additional core when needed to execute completely independent tasks in parallel, such as collecting online comments. So, On one hand, we have the extra process running on another core, which is responsible for gathering and classifying stock-related opinions from Reddit, all independently from the main process, which is here and handles asynchronous requests to an online LLM to generate the report for the stock at hand. Taking a look at the comment collection process, we see how we use the Reddit API to gather comments related to the ticker or company name. Then we load a pre-trained Roberta sentiment analysis model along with its tokenizer and use it to classify all comments as positive, negative, or neutral. In the end, we keep only the negative comments. Meanwhile, as we mentioned, the main process is making multiple requests to an online LLM to generate different reports about the company, which will later be combined into a single report. We can see this process in another Python file where the asynchronous function agents collect data is defined. This function also uses the AutoGen framework to define different agents for different tasks. As we can see, there is an agent for the general report, an agent for sector analysis focusing on the industry where the company operates, an agent for financial analysis, an additional agent that reviews any report and performs an online accuracy check of the information provided to validate if it's trustful or not. There is also a final summarizer agent that consolidates everything together. So, what we want to do first is we need to trigger 3 tasks asynchronously: the general report, the sector analysis, and the financial analysis agent. And each of them must be followed by the validator agent to verify the accuracy of the information they provide. We can clearly see that here each agent is followed by the validator agent. These 3 are completely different agents, but the validator agent is the same. And due to these 3 asynchronous calls, this means that depending on the duration of each request, we may have the same validator agent making only 1 or maybe 2 or even 3 different requests to the same API at the same time. So, if the same validator agent makes a new request, while a previous request is still being processed, we are going to get the result as none. One solution for that is to create 3 instances of the same validator agent, but with different names, like this here. Or another solution is to define the validator agent as we do here, so that each time we call the function createValidatorAgent, we create a new agent object on the fly as needed. And even if they are handling requests to the same API at the same time, they are 3 different objects, which means there is no conflict between them. Here we can clearly see how each coroutine calls an agent with its corresponding task, followed by createValidatorAgent and its task. We also need to keep in mind that the validator always requires the report generated by the preceding agent, as it is the information it will work on. So, what we actually pass as a new async.io task to the async.io loop is really this kind of wrapper here. This allows us to correctly organize the sequence of agents, where the agents that generates the report is followed by the validator that verifies the accuracy of that report. Therefore, in the end, the full task passed to each validator consists of a generic first part acquired when creating the agent on the fly, which we can see here. Let's take a small screenshot plus this extra component. The provided information is whatever the preceding agent has output. And now what remains is quite simple and straightforward. Once both parallel processes are finished, we collect the results. The negative comments are saved in complaints.json, and the reports that have been classified as trustworthy are merged into a single report using another agent. We then process all of the negative comments with another agent in order to summarize all of them into concise points. Once we have the main criticism points or complaints about the stock or company, we use another agent to find coherence or a connection between each criticism point and the full company report. That's the reason why this agent requires as input both the summary of complaints and the company report, just as we provided here. And now we have already a report that perfectly serves as a clear summary of relevant information. Now, the only thing left is to do a final polish, depending on the intended recipient of the report. For this, we could use what Autogen defines as a nested chat, and here is a little example taken from the documentation. However, what I don't like about nested chats is that they work sequentially, meaning that each agent only starts after the previous agent has finished. Autogen is great for clearly defining and organizing multi-agent systems, but they are going to operate sequentially, one agent after the other, taking some time. And here we have a situation where every agent must operate over the exactly same input, so there is absolutely no need to wait for one agent to finish before starting the next. So instead of using a nested chat, we can asynchronously launch 3 agents, each working on the same report, with each one focusing on specific suggestions for improvement, such as clarity, legal and ethical aspects, or just making the report sound more professional. Finally, all the suggestions are gathered and merged into a single set of improvements, and then one final agent is applied to incorporate those suggestions into the report, ensuring that it reflects the best possible version. And that's it. That's all for now. If I continue improving the code, I'll try to upload a new video with updates. As for now, it is just a sketch or sample idea of what can be done. There are, of course, many ways to expand and refine this system. For example, it would be great to include more data sources beyond just Reddit to collect opinions from multiple platforms, and also optimize a lot this comments gathering process. Would be nice also to add plots and data visualizations to better represent the insights gathered. Would be great to simulate the results of some basic trading strategies based on past data, like buying and selling following the cross of some indicators. And something that it's always very interesting for both cryptocurrencies and stocks is capturing the dates when news appears, whether on YouTube channels or TV news, and plotting that dates and the sentiment on a price chart. The insights of that is many times very surprising. So there are endless possibilities to make this code bigger and bigger.